hash table actually is an array of records. For example, for this hash table we have 101 records. Each record has a special field called key. In this example, the key is the integer field called phone number. When a hash table is in use, some sports contain valid records. For example, index 1, 2, 4. And other sports are empty. For index 0, 3, 5, so on. For insertion, the key must somehow be converted into array index. The index is called hash value of the key. For example, if we want to insert the value key is 2651556, and we need to find the key corresponding index. So we use 2651556 module table size 101. We get 3. The 3 is the hash value for the key phone number, and we use 3 to go to index 3 of the array to put the data into that slot. So the hash value is used for the location of the new record. So what is hashing? Hashing means we use a hash function to convert the key of the value into an index, then insert into hash table. The hash function is a function which transforms a key into address or hash value in the hash table. Hashing lacks indexing in that it involves associating a key with a relative record address. Hashing, however, is different from indexing in two important ways. With hashing, there is no obvious connection between the key and the location. With hashing, two different keys may be transformed to the same address, which does not happen in indexing. What can be hashed? We can say anything. You can hash on numbers, strings, structures, objects, so on. Where do we use hashing? In database, for example, phone books, student name lists, in computer chess games, in compilers. How to design abstract data type hash table? Of course, we have to use array to store the set of data. And then what operations we need to provide to hash table? We need to have a constructor to create the hash table. At the beginning, all locations in the hash table are empty. We need to be able to insert a new item into the hash table. We need to do deletion, searching. Therefore, those three most important operations are insertion, deletion, searching. How about the time complexity? For insertion, we just use hash function to find the key. We call hash the key. We find the index, and then we use the index to go to corresponding slot of the array. So the time complexity for hashing, for insertion operation is constant time. It's independent from the number of items inside the hash table. Big O 1. Same for searching, deletion. The time complexity is big O 1.